Guys, we made it, our very last talk of the day and the conference. Yay! Unfortunately, Shawn has some visa issues, so he can't be here, but there's going to be recording. But I guess, hi, Shawn. I'm still going to do the intro as if he's here. So here it goes. Guys, I've been seeing things lately. So I met this guy named Shawn Wang at CascadiaJS 2 years ago. And since then, I haven't been able to get rid of him. I was reading an article on Tailwind. He wrote it. React subreddit. He ran it. And the Svelte Society. He started it. I'm telling you, he is everywhere I go. And that's when I realized that Shawn is such a prolific writer, conference speaker, and now he is the founder and CEO of Small.ai. He is a true champion of what it means to learn in public. For the last time of the conference, give it up for Shawn Wang.
Hi everyone, this is Swyx. I'm so sorry I couldn't join you live. I was supposed to attend, I had bought my tickets and everything, but I was prevented from coming in through a series of very unfortunate events. We can talk about it more offline, but here I wanted to still give you my best on the state of AI engineering. I'm very fond of CascadiaJS, which is why I'm going to say yes whenever I'm invited to speak, just because I just love this community and family so much. It's a real bummer not to be able to attend. But just to kind of recap, the previously on in sort of Swyxverse. In 2020, I talked with you more about my career stuff, just because I had just published a book at the time, and I had a lot of learn in public and operating system thoughts that I wanted to share with people. Then in 2022, I was sharing more about my technical opinions, and actually I still hold very dear my speaker pass and attendee ticket from when it was in Oregon in the Sun River Resort. That was a really, really special moment as well. This year, we're back in Seattle, and I'm really excited to be sharing with you my thoughts, my updated thoughts on AI engineering, because it's really changed my life, and I do think this is going to be a topic of a lot of conversation from you guys, and I'm sure you're interested in what we're seeing in San Francisco as well. So this whole piece and my entire, I guess, credibility of why I'm talking about this to you today is because I wrote this piece on the rise of the AI engineer. And it really set off a series of events that culminated in me effectively pivoting my entire career to this. And I do think a lot of people are sort of in the process of this right now. And I wanted to show you the more important things that you should know about that. The central thesis is that foundation models and the rise of the large API labs effectively are enabling a big shift in how ML is being deployed into production. So in 2013, there used to be this popular XKCD meme where to do a very specific task, you need an in-house machine learning team. But roundabout in 2023, the state of AI progress is that you can change some few prompts and take the performance of something from 17% on a benchmark to 78% just by adding less things step by step. So that's kind of a meme. That's obviously one very, very narrow definition of progress, but it is progress, and it is, I guess, an indication of how things have really changed in terms of the kind of ability that you need for increasing the performance on a specific domain. We used to not have foundation models, and now we do, and now we can take them off the shelf from a lot of large model labs. Increasingly, I also find that people are asking questions about how to get started in AI engineering. This is a Hacker News thread that was fairly popular, and the common answers are either you go down this classical sort of machine learning path, or you go down the data engineering path. Since I left being a pure JavaScript person, which is heresy to talk about in a JavaScript conference, I have gone down a little bit of both paths. Right, I did a machine learning specialization in Georgia Tech, and I worked at a data engineer, and I can healthily endorse and qualify the statement that doing both of them doesn't necessarily set you up for a really successful career in AI engineering. So if that is broken, if that concept is broken, then what really is it, right? So this is the primary image to have in your head around defining AI engineering. Typically, you have the more established roles of ML researcher, ML engineer, and now there's sort of an API wall. This has always been there, but what that used to be occupied by on the other side was just a full stack engineer, product engineer, and that kind of stuff. But now that there is an increasing velocity of development in AI, what I'm seeing emerge is a dedicated role that is focused on keeping up and knowing the best practices, and that is coming to be termed the AI engineer. I think the other thing that's important to note as well is that the API wall is actually increasingly the wall between companies. It used to be the wall between teams internally within companies, but now it's between companies because the sheer amount of investment involved in the GPUs and the research capability and the staff and the data is all being walled up into the large foundation model labs. And now they want to serve their models as their products to the rest of the companies building the sort of last mile to the end user. So this is a very much of a demand and supply issue. And the two people that I quote now are Andre Karpathy, who says that there's going to be more AI engineers than ML engineers. And the other person is Ben Frischman, who is the founder of Replicate, also saying that there's basically about 2 orders of magnitude more AI engineers than software engineers, than ML engineers. And I think this is just true. You just simply don't need the level of qualifications that a typical ML engineer has. But also, I think that's more of a statement of lower social class, maybe, that the sort of entry barriers to entry might be lower, but actually there's also a lot of opportunities because the kind of person that is a good AI engineer may not be the same kind of person that is a good ML engineer. It's very much of a 0 to 1 mentality rather than a 1 to n. So I covered a little bit of this earlier. Here's just some charts. This image is from the Stability AI fundraising kickoff back in the day when Stability AI was the hottest company in town. But they actually started the sort of GPU arms race where entire startups would just raise money just to reinvest in NVIDIA chips, and that's definitely going apace. And there's also a sociological issue in the sense of there's just a lot of interest. This is my old company where we used to have one AI channel, and then we had more and more AI channels in my Discord, and now my Discord is just entirely an AI channel, right? It has definitely eaten and consumed a lot of people, and there's just a sheer growth in the amount of people wanting to work in AI that don't have the traditional background, that actually don't need the traditional background in order to be successful with it. I do also want to emphasize that it's not just like the why now of this. It's not just enabled by people's interest and hype. I think there is some real substance behind it because of the ability of foundation models to generalize across a lot of domains, to be specialized by prompts, and to do in-context learning with a lot of examples. So over here, there's an example that was taken from the GPT-3 paper, which I highly recommend reading. And on the right is on the vision domain with the segment anything model paper from Meta. Both of which all indicate the ability of foundation models to generalize very rapidly and then specialize with in-context learning. All of which means that you don't have to train the foundation model yourself. You don't have to build a team internally within your company to do that. You can grab one off the shelf, open source or closed source, and use AI engineers to do the tasks that a whole team of ML engineers used to have to do in the past, and do a better job than they used to do, because you just have sheer much more data, and the foundation model is generalized much better. Okay, the other thing I really like about sort of product sensibility is that we shift from a mindset of ready, aim, fire to fire, ready, aim. And so in what that means in the ML context is that you go from data, you collect a whole bunch of data, then you train the model, and then you serve that as a product. That used to be what a traditional sort of MLE process would look like. Now, with AI engineers, you MVP a product first, and only if that MVP is successful, then by sheer usage, you collect a whole bunch of data that's specific to that MVP, and then you can custom tune or train your own model, and that's the sort of a complete inversion of how the time to market has really shifted with AI engineering. It's really, really fascinating. The last piece, and the most relevant for CascadiaJS and the JS community in general, is that this is the first time that we've really had the opportunity to dabble in JavaScript, right? Like we used to have TensorFlow.js. I used to make fun of the TensorFlow.js talks in conferences. There will always be one, and there always be some really, really sad demo here and there. But now it's actually getting real and getting serious, and you can't really ignore it. I would say definitely Vercel has pivoted very, very nicely into owning the sort of AI TypeScript engineer. Here's Guillermo Rauch talking about how he believes that that the future of AI engineering is TypeScript. I will say that expectation has not really played out just yet. Here are the graphs of LangChain in Python and Vercel in Python and Llama Index in Python versus there are JavaScript and TypeScript equivalents. Definitely, by far, I'm finding that AI engineers will learn Python instead of rewriting the world in TypeScript, because Python is not that hard to learn. So that has some implications for the future of language-specific conferences versus more industry-specific conferences. As you might know, I've started my own conference that is language agnostic because of that. Okay, so why engineering and why not prompt engineering? Why this term AI engineers? I just want to give you some perspective on that. There's a very common and well-known progression from software 1.0 to 2.0. This very famous piece also by Andre Karpathy talking about what software 2.0 is. And basically, it's instead of hand-coded if, thens, and loops, you learn them through a whole bunch of data by setting up an architecture and just running them through with a normal sort of learning pattern. Software 3.0 is slightly different, where you're taking a foundation model and actually programming it, sort of post-training it from there, usually using in-context learning or prompting, as people might call it. I actually talked a little bit about this in my last CascadiaJS talk. So you can go to the 2022 talk that I did to find out more about that, because I'm not going to spend a whole bunch of time on it. The evolution that I've had since then is this core insight, is that AI plus code is actually way more powerful than AI plus language. And that is something I want you guys, all of you watching, to really internalize and understand. In that software 3.0 can generate software 1.0 code, and that is actually much more powerful than any sort of foundation model working in and of itself, right? So the best way to see that is the ability of LLMs to write code and augment their own abilities with code. In September 2022, we were just figuring out how to hook up GPT-3 to a calculator and a sort of Python REPL environment. By June 2023, this is when the general availability of OpenAI's code interpreter was released, and now you can generate all these charts and not need to know how to code, because the LLM can code for you, and that's just really fascinating. To me, this represents a big part of the progress, or the future progress of all these LLMs. If you can see that between each major version of an LLM, a core fundamental insight has really introduced that level of growth. Between 3 to 3.5, it was instruct tuning, and that spawned ChatGPT. Between 3.5 and 4, it was the mixture of experts that caused a huge jump in capabilities. And between 4 and it's effectively 4.5 or 4.0, it's the ability to write code and to operate in other modalities as well. But code is the most important modality by far. I'll skip this special piece, but I do think that understanding like where the significant value is accruing. We started off with GPT-3 with GPT 1, 2, and 3 with pre-training, but it's increasingly going towards the reward modeling and reinforcement learning that is driving more and more of the value. I think the latest numbers that I have heard, which is that Llama 3's core pre-trained data set versus their reinforcement learning and reward modeling data set, they're spending about the same amount of money, whereas it used to be a lot less money on the sort of post-training sections of their reward modeling. The other element of the sort of software 1.0 plus 2.0 equals 3.0 thesis is that there's a really core schism when you write these apps about where code should live, right? A lot of like the ChatGPTs of the world are really essentially a thin wrapper shell around a LLM core. They basically translate user input with whatever affordances into something that is just piped out into a string and fed to an LLM, and the LLM decides and then spits it out again, and that's about it for the application. Increasingly, I'm finding that people run into limitations because this application is only as smart as the LLM will be, and really it's unpredictable, it's unsafe, and prone to all sorts of issues. Actually, you want to break things up and switch towards a code core thing with sort of LLM at the shell or LLM at the edges, and that actually might serve you a lot better. So I do want you to understand as an AI engineer this fundamental distinction that it's very good, it's very useful to do both, but having an idea of what kind of architecture you want to adopt is probably one of the biggest decisions you'll make as an AI engineer. Finally, the sort of emergent architectural discussion around AI is the concept of the LLM OS. I had an early version of this in a piece called The Anatomy of Autonomy, but nowadays I'm probably encourage people to not use human brain analogies because LLMs and artificial intelligence evolves very, very differently from natural intelligence. In fact, I'll push you more towards the sort of operating system analogies because they have much more physically constrained limits, and it's much more conducive to think about engineering from that point of view. So LLMs all have context windows, and then basically you have to page in context in and out of the context window with a broader corpus of retrieval augmented generation databases. But then you also want to hook them up with tools. You want to have different input devices, and then you want to connect them up to the internet and other LLMs. I think this model really, really holds. If you look at the literature of how we structure my course on the InSpace University, we basically follow that exact guide and tour through the modalities. And finally, we also talk a lot about the sort of four wars of the AI stack, right? Like what people are really fighting over, and what are the unknowns that will be basically the substance of what people are fighting over the next 5 to 10 years, let's call it. So people will be fighting over data, people fighting over GPUs, people fighting over whether you have a lot of different models or one single God model that does everything, and people will be fighting over RAG and ops. Here are the main players within that space. If I definitely refer you to that latent space piece if you want to read more. I don't really have the bandwidth here to to discuss it because it would be its own, and we've already done a bunch of versions of those talks. My goal here is to give you an overall state of the state of AI engineering, right? Which I think is why I'm here. So when I was in this sort of data engineering world, which is last time in Cascadia 2022, I always talked about this whole overwhelming stack that people like to put out there. And I always want to encourage people, if you want to make sense of a landscape, to always simplify, right? So this is what I did in 2023 for the modern data stack, which is instead of all those confusing diagrams, like just take the things that are actually valuable. Instead of weighting by number of logos, you weight by amount of value, like economic business value actually created, and you simplify a lot to warehouse pipes and business interface, and then a whole bunch of observability and ops stuff that isn't as valuable in AI. Okay, so what is the equivalent for the AI stack, right? In 2023, I did this, which was foundation model labs. So basically closed source labs and open source labs, or open source hosting. There's pipes as well, and there's vector database, and then there's the user interface, right? And we can talk about the main players of each. So you need to know, for example, I expect every AI engineer to know these names on the left, these names on the right for hosting your models if you're open source, or choosing your models off the shelf for closed source. And then these names on the left for vector database, and these names on the right for coordinating with those vector database. These are sort of the RAG frameworks. And then finally, the last piece is sort of the most emergent piece, which is the ops stack. There's a lot of sort of operations names as well. I will stand by all of these as names to know if you're shopping for your sort of ecosystem of AI engineering tools. And they all look like this, right? Their landing page all looks like, we will track your prompts for you, and we will tell you how much you've been spending. Not have any opinion about how you should be building your products because they're trying to build a horizontally applicable tool. The most interesting for JS engineers and UI engineers is still up for grabs, surprisingly, even like 1 year after I made this original chart, which is like, what is the user interface of AI, right? A lot of people are talking about chatbots, but I think people are increasingly coming up with new and useful tools that are not just chatbot. So Vercel v0, I think a lot of people at this conference will be familiar with, but it's really good for prototyping UIs. I think it should be a part of the core toolkit for most AI engineers as well, for anything front end. And second, for internal facing tools, I do think that you want some kind of UI interface to chain things together. Retool AI is really good at it, but there's a whole bunch of others, Langflow and BuildShip and all the other startups that are all canvas-based UI elements. If you're interested, I have held a AI UX meetup where people have shown off their latest and greatest in those tools, and they're on YouTube as well. Okay, so coming back to the LMOS, I definitely recommend these two folks. One still at OpenAI, the other one ex-OpenAI, just talking about their sort of OS experience. But really, I would actually direct you towards the evolution of ChatGPT and maybe now Anthropic as well, which is that every single one of these like toggles and buttons within like a new GPT creation process is a startup and is part of the LLMOS, because they all have independently discovered the need for one of these things. So for example, you need a knowledge base, you can use a vector database, or you can use an orchestration framework. If you want to hook your LLM up to the internet, you can use Perplexity, browser-based, or Exa. If you want to have image generation, you can use any of the image generation companies. Same for code interpreter, same for hooking up with external APIs for Zapier. An increasing important thing for long-running agents and personal assistants is basically the concept of a memory agent. So memory is an emerging field. I would encourage people to check out LangMem from LangChain and MemGPT, which is a paper that's now become a startup. This is much more speculative. On the stuff on the right is much more speculative than the stuff on the left, but I think it's also really worth checking out. The final piece is just security, which I'll call out here. There's obviously a lot of things to call out, including speech and other controls. But security, I do think it's underrated and something that builders always want to leave towards the end. But having an important sort of security component that solves everything is really helpful. A friend of mine just got acquired by OpenAI just to provide this layer for all of OpenAI. But you can check it into Anon if you're interested in security. More broadly than that, I think domain-specific ChatGPTs have really been the story. So this is a story I did earlier this year, talking about why in the past 1 year, in the past 12 months, ChatGPT's numbers or user growth numbers have been zero. There's been zero growth in ChatGPT because people have been unsubscribing. Like I have unsubscribed from ChatGPT myself. And because I just find like so much more domain-specific use cases that actually do what I wanted to do. So the GPT App Store actually might be a better place to hunt for business ideas than actually writing GPTs and trying to earn revenue from ChatGPT itself. So I really encourage you to look for opportunities in all these areas because the LLM OSs of the world, which all these components, that ecosystem is really maturing for the AI engineer to build their own part of the kingdom instead of everything going into ChatGPT. I will also note, I guess, that OpenAI is like completely fine with this. They have no issue with enabling their own competitors because it's not about making money from ChatGPT for them. It's more about making intelligence available to everyone. Okay, so where to start? A lot of people ask me this. We have created our own sort of little course that is taught on Latent Space University because we want to trigger the Tigers fans. But also, we also teach a live cohort session on maven.com, which is starting. What about AI engineering in industry, right? Like where instead of if you think everything I've talked about is very basic, how do you learn from the best? I actually happen to be organizing my own conference now. Going from conference speaker to organizer is a very, very big jump. And I'm not sure I'm ready for it, but whatever. This is my conference that's happening next week. That is basically serving the field of AI engineering, and I've invited the best of the best from every single industry and domain. And that's about it. I wanted to make this remote talk short. I'm very sad and apologetic that I couldn't make it in person, so I wanted to give you back that time. Then also just tell you that I'm still here. I'm still online. I'm still easy to access and talk to. Find me at AI Engineer or find me at Latent Space, my podcast and newsletter. Thank you so much, and have a wonderful CascadiaJS. Thanks.